Since its discovery, Proxima B has stirred excitement and curiosity in the scientific community. This alien world, orbiting the closest star to our solar system, has long been suspected of harboring a tantalizing secret. Not only does it possess Earth-like dimensions, but it also resides within the habitable zone of its host star, raising the intriguing possibility that it could support liquid water, and potentially, life. Let's start with a fun quiz question. How many planets are there in our solar system, 8 or 9? Do we still count Pluto? The answer isn't so straightforward, especially when we broaden our view beyond our solar system. In fact, we must not forget the existence of countless planetary worlds outside our home system, planets that orbit stars other than our Sun. These are known as exoplanets. As of now, astronomers have confirmed the existence of 6,911 exoplanets in 4,941 different planetary systems. And yet, this astonishing number is only the tip of the cosmic iceberg. Experts estimate that there could be as many as 50 billion more planets within the Milky Way galaxy alone. With numbers like that, the dream of discovering an Earth 2.0 doesn't seem so far-fetched. Increasingly, scientists are answering one of humanity's oldest questions: are we alone in the universe? With a confident and resounding no. But that raises another important question: is it even possible, from our relatively fixed and distant position here on Earth, to catch a glimpse of these potentially life-bearing worlds, many of which are millions of light-years away? The answer might surprise you. Perhaps it isn't even necessary to search the farthest reaches of space to find life. Why look across the universe when the next alien civilization could be slumbering just an astronomical stone's throw away? That's where Proxima B enters the story. No other known exoplanet comes as close to Earth as this intriguing world. Proxima B is located in the constellation Centaurus and orbits the red dwarf star Proxima Centauri, a part of the Alpha Centauri star system. Discovered in August 2016, Proxima B lies just 4.2 light-years away from Earth. And yes, that might sound like a small number in cosmic terms, but make no mistake, it still translates to a staggering 37.84 trillion kilometers. With our current propulsion technology, it would take thousands of years to reach Proxima B. Luckily, humanity has now advanced to the point where we can study distant cosmic phenomena without physically traveling to them. Thanks to powerful telescopes and detection methods, we're able to analyze and understand distant worlds like never before. Interestingly, Proxima B isn't alone in its star system. It's accompanied by at least 2 other planets, further complicating and enriching the narrative of this nearby exoplanetary system. But how do scientists detect such distant objects in the first place? Are modern telescopes like the James Webb Space Telescope truly capable of directly imaging alien worlds? The answer, for now, is not quite. While these instruments are incredibly powerful, direct imaging of exoplanets remains extremely difficult due to the brightness of their parent stars and the vast distances involved. Instead, scientists typically rely on indirect detection methods. One of the most successful of these is the transit method, where a planet reveals its presence by slightly dimming the light of its star as it passes in front of it. However, Proxima B wasn't discovered using this method. Instead, astronomers used the radial velocity method, a technique that detects a planet by observing the slight wobble it causes in its host star due to gravitational pull. Even though these wobbles may shift a star by only a few centimeters, they're enough to clue in planetary hunters that a new world has entered the scene. Now that Proxima B has been detected, the natural question arises: what kind of planet is it? More importantly, is it potentially habitable? To be classified as potentially life-supporting, a planet must meet several criteria. First and foremost, it must orbit within the habitable zone, a sweet spot where conditions are just right for liquid water to exist. Proxima B meets this requirement. But the story doesn't end there. Other crucial factors such as the planet's atmosphere, magnetic field, and the radiation output of the host star also play vital roles in determining habitability. Proxima B is estimated to have a mass of 1.17 times that of Earth, which places it in the category of Earth-like exoplanets. However, we should be cautious about the term Earth-like. It doesn't necessarily imply that the planet is habitable. It simply means that the planet is rocky and has a solid surface, as opposed to being a gas giant like Jupiter or Saturn. One key difference between Earth and Proxima B lies in their orbital periods. While Earth takes 365 days to orbit the Sun, Proxima B completes a full orbit around its star in just 11.2 days. This incredibly short year is due to its close proximity to Proxima Centauri, only about 7 million kilometers away. You might think such a close orbit would make the planet unbearably hot, but that's not the case. Why? Because Proxima Centauri is a red dwarf, a much cooler and less massive star compared to our Sun. It has only about 12% of the Sun's mass and emits far less heat and light. Another fascinating aspect of Proxima B is its likely tidal locking, meaning it always shows the same face to its star, just as the Moon does to Earth. This results in one hemisphere being in perpetual daylight and the other in eternal night. While this might sound like a deal-breaker for habitability, simulations suggest that a narrow, twilight zone between the hot and cold hemispheres could host temperate conditions. This narrow strip might be the sweet spot where life could potentially exist. Moreover, researchers propose that glaciers on the night side could melt near the twilight zone, feeding lakes and rivers with fresh liquid water. These dynamic systems might create localized climates suitable for life. But what kind of temperatures are we talking about? Calculations show that the equilibrium temperature of Proxima B could be around -39 degrees Celsius. It's worth noting that the equilibrium temperature doesn't necessarily reflect the surface temperature. If the planet possesses a functioning atmosphere, greenhouse effects could raise surface temperatures substantially, just like they do on Earth, which would otherwise sit at a chilly -18 degrees Celsius without its atmospheric blanket. Despite these optimistic signs, the big question remains: has life already developed there? The answer largely depends on factors we haven't yet confirmed, such as the presence and composition of the atmosphere, magnetic field strength, and planetary history. Some simulations, assuming favorable atmospheric conditions and orbital stability, suggest that liquid water could indeed persist on Proxima B. However, there's a big challenge to overcome: Proxima Centauri's extreme stellar activity. A few years ago, researchers at the University of Colorado observed a colossal flare erupting from Proxima Centauri. While our own Sun frequently produces solar flares, this particular outburst from Proxima Centauri was 100 times more powerful than anything we've ever recorded from the Sun. In a matter of seconds, the star's ultraviolet radiation increased by a factor of 14,000. Such frequent and intense flares pose a serious threat to any atmosphere a planet might have. Given this, it's reasonable to assume that such radiation could strip away Proxima B's atmosphere, eliminating any chance of sustaining life. But not all hope is lost. If Proxima B has a molten iron core, it could generate a magnetic field strong enough to deflect harmful radiation, much like Earth's magnetic field protects us from solar wind. This would help preserve essential atmospheric components like oxygen and water vapor. There are also other possibilities. Proxima B might have formed farther away from its star and was later drawn inward, giving it a different atmospheric and geological history than if it had formed close in. Some models even suggest that the planet may have once held 10 times more water than Earth. And even if 90% of that water were lost to stellar flares, the remaining 10% could still support a vast global ocean. This ocean, located mostly in the twilight zone, could remain at moderate temperatures due to the balance between the frozen night side and the scorching day side. Ultimately, while the existence of life on Proxima B remains unconfirmed, the possibility has not been ruled out. With the discovery of new exoplanets happening almost daily, and with ever more powerful telescopes like the James Webb Space Telescope helping us peer deeper into the cosmos, we are edging closer to answering that age-old question: are we alone? And perhaps, just perhaps, the answer lies in a small rocky world just 4.2 light-years away. Stay curious, stay inspired, and stay with Space Lab. Your journey through the stars continues here.